All right, now you can guess where we're going with this. We have the same atom, oxygen, 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 oxygen. Same type of resonance in the conjugate base, right? So we have O minus here, and that can delocalize into the carbonyl. That charge is shared, more stable, okay? So then how do we differentiate between the acidities of all these, right? We know the pKa for the parent compound here, acetic acid, is around 5. If we go and add a bromine to this at the what's called the alpha position, if I use the Greek letter alpha, we get a pKa of 2.86. So that lowers it by 100 times, 2 orders of magnitude, right? And then we go down to 2.81, so there's a small difference there. And then the last pKa with the fluorine here is 2.66. Okay, so what can we use to explain this, right? Why? The big question. Okay, so bromine, chlorine, and fluorine are all halogens. They're more electronegative than hydrogen. And so this is where we get into inductive effects, where we have nearby electronegative atoms. So these atoms will be withdrawing electron density from the, well, this one not so much, since that's my parent kind of standard compound that we're comparing it against, okay? So if we have an electron withdrawing atom, such as one of these halogens here in the conjugate base, we will see that when we have a negative charge nearby, this inductive withdrawal would be kind of stretching some of that negative charge, stretching that cloud of electron density. And, you know, if you're stretching the cloud, making it a little bit bigger, you're giving those electrons a little bit more space, and a little bit more space for those negative electrons that repel other electrons is good, okay? So, inductive withdrawal, you're stretching that cloud of electron density, you're making it a little bit bigger, making this a little bit more stable, and therefore this is getting weaker. Okay, and you can see as we increase electronegativity from bromine to chlorine, we have a would be a even weaker conjugate base and a stronger acid. And the alpha fluoro acetic acid is going to be the strongest in this family because the fluorine is the most electronegative. It's most able to inductively withdraw that electron density. Okay, so keep in mind that this is a nearby atom or group, right? This hydrogen is not directly attached to this fluorine atom, so we can't use the atom rule. We have to use the induction rule because this is attached to oxygen, as it is in all these cases. They have the same resonance, so we have to move on to the third criteria, is induction. Are there any groups that are going to inductively withdraw to stabilize this ion?